Okay, so now we're moving on to 11.3, volume of pyramids and cones. And just like in the previous chapter, chapter 10, when we did area and all, so far in the chapter 11, every one of them, you've been given formulas to work through. And again, now we're looking at the volume of a pyramid, and here is the formula that you need. It's 1/3 times the area of the base times the perpendicular height. Okay, and then when you look at the diagram, don't forget the perpendicular height has to be from the center to the apex of the pyramid. And here's the concept summary. This is all the formulas that you will need, but don't forget we're just doing the last two this time. We're just doing pyramids and cones. Okay, so your pyramid is 1/3 times the area of the base times the perpendicular height, and actually that's the same one for the cone, but if you realize that the base in this case, instead of it being the area of the base, is pi r squared, so there's a slight change in both of them, but if you think of 1/3 the area of the base times the height, you shouldn't have any problems. Okay, so let's have a look at question number 1. First thing you need to notice, it's a right angled triangle, so it's area equals 1/3 of the base times the perpendicular height. Well, in this case it's 1/3, and then it's a half base times height, that's the area of the triangle, and your height is given there. So now start substituting in. It's 1/3, and all these are actually multiplying, so if you think about it, it's 1/2 times the area of the base. Well, that's 5 times 9, and then the area of the perpendicular height is 10, and if you plug all that into your calculator, you will get 75 inches. Inches is the units, and don't forget it's inches cubed. Now we're going to find the volume of a cone, but don't forget with the volume of a cone, the h is the perpendicular height. Okay, some of them, don't forget, we've had the slanting height, which in previous chapters, in chapter 10 and a bit of this, that's the slant. Okay, so you need to look to make sure you've got the perpendicular height, but again it's the same thing. It's 1/3 pi r squared h. So if we look at question number 5, okay, so we've got area is equal to 1/3, okay, and the base is pi r squared, and then the height is 4. Okay, so all you're going to do now is substitute r for whatever the radius is. Okay, and again we're all multiplying, so that's 1/3 times pi, and don't forget the diameter is 7, so the radius is 3.5. And don't forget you've got to square that, and you're going to multiply all that by 4. So again, everything is multiplying. It's a calculator job, and if you do that and put it in your calculator, round it to one decimal place, you get 51.3. And again, check the units. Again, in this case it's inches cubed. Alright, so now we're putting that into real life situations. Okay, we're doing the square base pyramid at the top of Washington Monument, and again, real life, until I read that, I didn't realize that nothing in DC can be bigger than 555, so you're learning a bit of extra stuff as well. All right, but again, quote the formula: 1/3 base, the area of the base, times whatever the height is, and then whatever you've got, just plug it in. And again, it's calculator, so it shouldn't take you too long. Okay, so again, let's have a look at example 3 in its real life. It says that the Caddo Indians live in tall cone-shaped grass huts. So the moment you see it's a tall cone-shaped, so your formula is going to be A equals, and it's going to be 1/3 pi r squared h. Okay, so again, calculator job, 1/3. I'm putting everything in parentheses again, pi. The radius, it does tell you that the diameter is 40. Well, obviously the radius is 20, so that's going to give you 20 squared, and then the normal height is 40. And again, if you put that all into your calculator, actually you get quite a big number. It's 16,755 feet squared, cubed. Okay, so you've got quite a large area in what is actually their grass huts.